In 1977, a math professor bought her condominium in Cambridge, Massachusetts for $70,000. The value of the condo has risen steadily so that in 2007 real estate agents tell her the condo is now worth $850,000. A. Find a formula to represent these facts about the value of the condo V of t as a function of time t. B. If she retires in 2010, what does your formula predict her condo will be worth then? Some of the key words to pay attention to. The value of the condo has risen steadily. Suppose there's different interpretations that you could use for that, but the way that I'm going to think about it is that it's been rising by the same amount each year, or at least approximately by the same amount each year. So that indicates that a linear function would be the best model for this particular situation. So let's go ahead and recall. What does a linear function look like? Well, it has the form f of x is equal to ax plus b, where a is the slope, or in an application, the average rate of change. And b, graphically, it's the y-intercept, but in an application, it corresponds with the initial, or the beginning value. Now, for this particular problem, in order, the beginning value, the value of the condo initially was $70,000. In order for that to be the beginning value, we're going to have to define t not just to be time, but the time in the number of years since 1977. So 1977 is going to be the beginning year, and so we want time equals 0 to correspond with that. So we'll have v of t as a function of time t, and I'm going to add to that where t is the number of years since 1977. Alright, so by doing that, our beginning value will be $70,000. What we'll need to do is to figure out the average rate of change. So what is the average rate of change? Our a value, first of all, we'll need to find the increase in the value of the condo. To do that, we'll find the ending value, 850,000, subtract the beginning value of 70,000, and divide that by the total amount of time that it took for the increase to take place. Well, from 1977 to 2007, that's a time period of 30 years. So we go ahead and do that calculation. 850,000 minus 70,000, all divided by 30, and it ends up being $26,000 per year. So the value of the condo has been increasing steadily at a rate of $26,000 per year. So now we can write down the function. Now notice that the name of our function isn't f, the name of our function is v for value. So we'll write v of, we're not using x, we're using t for time, where t is the number of years since 1977. So v of t is equal to our average rate of change, which we just calculated to be 26,000. Multiply that by the number of years t, and then add the beginning value, which was 70,000. We can now use that function in order to help us to answer B. If she retires in 2010, what does your formula predict her condo will be worth then? Well, the first thing we'll have to do is to figure out the number of years since 1977. So we'll take 2010 and subtract 1977, and that comes out to be 33. So we'll want to substitute 33 for t, and we get v of 33 is equal to 26,000 multiplied by 33 plus 70,000. And when we do the arithmetic, we end up with $928,000. So to answer the question, if she retires in 2010, what does your formula predict her condo will be worth then? It'll be worth $928,000.